Okay, class, this is 20.2 screencast for the notes, balancing oxidation reduction equations. It says perhaps the easiest way. I'm not sure of any other way that we can balance redox equations. Redox meaning oxidation reduction, but they changed it to reduction and then oxidation. So redox is like the shorthand for saying oxidation reduction reactions. Half reaction method. So it's really not it's not super confusing, but you do have to practice it because like everything else in chemistry, there's like rules and there's a lot of stuff you have to know for background information. So it does get a little confusing, but we're going to go through this. Try not to make this video last 20 minutes, so let's just keep rolling here. Balancing, this involves treating on paper only the oxidation and reduction as two separate processes, and then we're going to put them back together then at the end. So first of all, when we're doing half reactions, here's the first thing we need to do. We need to assign oxidation numbers to determine what's being oxidized and what's being reduced. Then we write the oxidation numbers and like we write those things that are being oxidized together, write those things that are being reduced together. Okay, here I'll show you what I mean. To go through this stuff here is maybe not as easy, like I can talk about it, but I'd rather show it to you. So this says, I'm just going to say it quickly, balance each equation half reaction. Balance the elements other than H and O. Balance O by adding oxygen, so O and oxygen. Balance H by adding H+. I'll show you what that looks like then. Balance the charge by adding electrons. This is the big one. That's the important part. And then multiply the half reactions by integers so that the electrons gained and lost are the same. And I'll show you how to do that, of course. So add the half reactions, subtracting things that appear on both sides, and make sure that the equation is balanced according to mass. Okay. And then make sure it's balanced according to, so here's our first equation where we have permanganate and oxalate, and then over on the right-hand side we have the manganese plus 2 and we have carbon dioxide. Okay, so that's what's happening here. Notice that we have not just manganese and carbon on both sides, but we also have oxygen. So I'm going to show you how to handle this. Now, the first thing we're going to do, as it shows you, is we're going to find out what the oxidation numbers are for these. I do that, I want to make sure that you guys are still good understanding how to do this. If we have a polyatomic ion, whatever the charge of manganese is must be added to the charge of oxygen, and it has to equal whatever the charge of the polyatomic ion is. So here's what we do know. We know that oxygen always a -2, and there's 4 of them, which is a -8. So what completes the sentence of something plus a -8 equals a -1? And our only real choice is +7 for that. And that's how you find the oxidation numbers for these. This works exactly the same way. CO2O4 -2. There's 4 oxygens, each one's a -2. Again, that's a -8, except this time it's going to equal a -2, so that means it must be a +6, right? Well, because there's 2 carbons here, then we divide each one of those by the 2, and that gives us our +3. That's how we got the +3 there. Okay, now these are pretty simple because that's Mn plus 2, and here's our CO2, which means that if each oxygen is a -2, and this is a compound, that means that that plus that is going to equal 0. So that's a -4, which means this must be a +4. Okay, that's a -4 because a -2 for each oxygen times 2 gives me a -4. Now, once we get to this point here, we notice that, and I always use the number line. If our numbers are going to the right, it's being oxidized. If it's going to the left, it's being reduced. So from here, I got, let's see, 1, 2, 3, 4, 5, 6, 7, 8. So let's say this is 0, 1, 2, 3, 4, 5, 6, 7, 8. So that means that these are all pluses here. So I go from a +7 here to a -2 here. This is reduction. Okay, this is being reduced. Here I'm going from a +3 for my carbon. Is going from a +3, I'll use this different color, +3 to a +4. That is oxidation. Okay, let's keep going. So we're going to start off with the oxidation half reaction. So the first thing I do is I balance. I have 2 carbons on the left-hand side and I only have 1 on the right-hand side, so I put the 2 in there. So the 2 goes in just to balance the half reaction, anything that's not an oxygen or hydrogen. So now I have 2 carbons, and over here I have 2 carbons and 4 oxygens. So to balance the charge, we must add 2 electrons. Notice I don't have to balance the oxygens at all because I have 4 on both sides, so that's good. So here, if I'm going from a +3 here to a +4 here, that means in total I'm going from a +6 to a +8. So to get these two to be the same, I need to add 2 electrons to this side, because then it gets to be a +6. Remember, electrons are negative, so that means I'm adding 2 minus charges, or another way I could write that would be to -2 would give us the +6, and the only way I can -2 is to add 2 electrons. Okay, so 2 electrons on the right-hand side. Another way to remember this is, if we have an oxidation, then the electrons go on the right-hand side as a product. If we have a reduction, then the electrons go on the left-hand side as a reactant. That is always the case. So oxidation, half reactions, the electrons are products. Okay, good. Let's keep moving. So reduction to half reaction. Now this one's going to be a little different because I have oxygen on one side and now on the other side. So I'm going to show you the other parts to this. So this is +7 and this is +2. So that means I'm going to need to get rid of 5 plus charges, and I do that because of reduction. The electrons are on the left-hand side. So, oh, I'm jumping ahead of myself here. We have 4 oxygens on this side and none on this side, so I add, bonehead, I add 4 waters. That gives me 4 oxygens on both sides, but we're not finished yet. So, and it says to balance the hydrogens, once I have 4 oxygens, waters on the right-hand side, that means I have 8 hydrogens that I need to add, and I do that over here by plus hydrogens there. You can see that down here. Keep moving. Now we get to this part here, and we need to add 5 electrons. If it's reduction, which this is, that means the 5 electrons go on the left-hand side, just like I earlier stated. Okay, now we've got the 2. We got the C2O4 with the -2 yields 2 CO2 plus 2 electrons. Here I have 5 electrons. Okay, so first of all, the very first thing we need to do is to multiply this one by 5. That's the whole thing. Okay, and we need to multiply this one by 2. The whole thing, like that. So that means it's going to change. This one's going to change to 5C2O4 minus 2 to 10 CO2 plus 10 electrons. Okay, you have to get 10 electrons for both of them. So this would be 10 electrons plus 16 hydrogen plus 2 MnO4, the -1, this is 2Mn with a +2, plus 8 H2O, just like that. Okay, so that's what it's going to look like over here. I've multiplied all the stuff through. So now it says when we add these together, we get all of this. We can get rid of the 10 electrons and the 10 electrons. That's what we're supposed to do. Everything else, there's no, sometimes you'll have hydrogen on both sides, sometimes you'll have water on both sides, but we don't need to cancel any of those out because the water is only on the right-hand side and the hydrogen is only on the left-hand side for this. So that is literally how we combine the half reactions, and our final answer is what you see at the bottom then. Okay? So we are going to go over that. Now, I do have to say this is the last slide in the presentation here. So balancing in basic solution, you will never balance in basic solution with me. It's one extra step, but it's not worth doing because you won't see it on the AP exam, and I'm certainly not going to put this on a test, so don't worry about balancing basic solutions. All right.